So, since we are confused with whatever flow it is, now we are going to continue with this part. What we do is, firstly, let's assume as laminar flow. Okay, we are just assuming laminar flow. Now, if this laminar flow, we know that the velocity is equal to 4 by 3 GD rho P minus rho W divided by rho W into C. I'll put velocity square, okay? So, CD will be equal to 24 by R, 4 by 3 G D rho P minus rho W divided by 24 divided by Reynolds number into rho W. Now, we know that Reynolds number is equal to velocity into diameter into rho divided by mu. Here, mu is dynamic viscosity. Okay. So what we do is here 4 by 3 G D rho P minus rho W divided by rho W 24. RE goes up. Instead of RE, what I put is velocity into diameter into rho W divided by mu. This is the Reynolds number. Okay. So this and this can be cut, and then this is velocity square. So this velocity can be cut. So now what happens is velocity is equal to 4 and this 6, 3 6 are 18. 1 by 18 G, this twice D square rho P minus rho W into below or in B. This is the final equation of this. Okay? And this equation is called Stokes law. Stokes equation, or we call it Stokes law. The derivation of the here itself is sometimes asked, maybe 20 marks or 30 marks based on that of the exam. I didn't know if you got to just have a glance for 20 seconds. And in between, I'd like to inform that I cannot do the recording for a very long time because the memory of the mobile and difficulty in uploading the YouTubes. So for your benefit, I'll just cut part by part and I'll upload. Okay. So this is Stokes law. Is it clear? This derivation itself here you should practice and you should do it. Okay. Now, since mu, what is mu? Kinematic viscosity. Is equal to the dynamic viscosity divided by density. Okay. So what we can do here is velocity is equal to 1 by 18 GD square rho P minus rho W divided by, instead of mu, what I'll put is into this rho is nothing, it is rho W. Okay. So if you put this way, velocity can be 1 by 18 G D square by kinetic viscosity, and this is nothing as specific gravity minus 1. This is also same. This also Stokes law in terms of kinetic viscosity, and another one in terms of dynamic viscosity. Now here, the derivation of the viscosity, Stokes law, it's over. Fine. So if any particle is given like d, the diameter of the particles, then the kinetic viscosity or the dynamic viscosity will be given always, because what type of liquid it is settling down, that is not known to us. So value will be given, specific gravity will be given, g is 9.81 meter per second square, so you can find the settling velocity. But the problem is, this is as per the assumption that the flow is laminar, but we are not very sure whether the flow is laminar or not. The next question comes, estimate the settling velocity of a particle of this particular size. How to approach? Okay, so you check up to here. Is that okay? Fine. So I'll rub it off. Now, my dear students, what I would like to tell to you is, this is the first class, I'm recording piece by piece. Before solving the problems, next one is I'm going to solve the problems. This is just a derivation. Solving the problem is a little bit tough. The reason is, while solving it, I need someone to tell me what is the answer by calculator. Then when you're not going to help me out right now, then I have to mug up all the values also. So before that, you listen this properly in the YouTube, give me the feedback. The feedback should be like, sir, you speak very fast, your handwriting is not good, or lightning is not very high, but you have to have some constraint also, because this is inside my house, okay? I will give you an excuse. But the main point like, sir, you keep it a whiteboard for sometimes the equations, or you move a little slow, or you rough a bit slowly, or after finishing the equation, please repeat once again, something like that. If that is easy for me, I can at least upload 3 videos every week, or minimum 3 to 5 videos a week. So covering the syllabus won't be a big deal for me. In the meantime, I will also send you the class notes, like the different type of sedimentation class notes. Rather than writing over here, I'll send you the class notes. You don't worry for that. But please give me the feedback. Let me wind up here for this first class. Before solving the problem, I would like to have your feedback and let me solve. Or you say, I'll give you the questions, you try yourself, or I'll send you the class notes, and then you say, sir, we'll try ourselves. If we don't know, we'll ask. Because if I solve over here, I need a calculator, and I cannot do calculator myself. It's not easy for me. So try to give some feedback how we can solve a lot of numericals. Okay? With this, I need a feedback from all of you students, my dear students. I'll give my level best to sort out the things, because another reason why I'm saying is, I used to take a lot of tuitions when I was at Delhi College of Engineering. I used to give tuitions to many engineering service students. Here also, I used to make question papers, I used to make viva. And since I'm much knowledgeable in this topic, why should my dear students, you people who are coming to NIT Manipur, suffer without my knowledge transferring to you? So I like to give my best shot to you, so that in the future you remember me, okay? So give my feedback very properly. From now on, we'll continue the class this way along with the class notes. Fine?